Take it away.
Hey everybody, my name is Michael Hernandez, and my presentation is on the mouse of the future. As you can see right here in my right hand is the bulk of my project, and as long as this works, sometimes it's not as responsive as I'd like it right now. So the problem statement is I want to seamlessly and affordably be able to track the movement of your hand, left, right. You can see it's working more like an analog stick right now than a mouse itself, but it's still usable. I've actually had 4 separate computer science students use it, and within 2 minutes of getting to know the quirks of the machine, they've actually been able to use it successfully. Alex shaking his head right there because he's been able to as well. All right, little button here so I can turn it off so I can just click manually. The functionality, very obvious, just to move the mouse according to your hands and to right click with the finger. Steps taken to do this, and I have a diagram to show this later on as well, but we have multiple sensors here. We have the accelerometer sensor so that you can read the movement of your hand. We have flex sensor so you can read the movement of your finger. And all that data is sent into the Arduino itself, where then I have personally made a digital filter that will filter out the noise that it comes with using analog signals and having a bunch of wires together. And then the data will be sent using a 433 megahertz transmitter to the receiver, which is also a 433 megahertz receiver. And that data is then further filtered so that I can kind of understand movement differentiated between right and then right and forward. And then it moves the mouse itself. So here's the diagram, and we're going to go into it. And I'm going to start by talking about the haptic data or the sensor data. So the accelerometer is how we obviously get the movements of the hand in the X, Y, and Z position. It talks with the Arduino via a master-slave relationship, meaning that I have an input and a clock pins, meaning that the master is the Arduino and the slave is the accelerometer. The clock is how it dictates at what speed the accelerometer talks to the Arduino. And that is how we get the information to the Arduino itself, and that's how we get it. And the next point we got to do, though, is we have to filter the data. And I will show you later on, I have multiple graphs, but the data doesn't just come, I'm moving 9 meters per second to the right? It comes in variance up to 3,000 to 3,500 and variance all around that. And so my challenge then is to find the change in which this is happening and filter out that extra noise so I can get relatively decent values to move throughout. The haptic controller, also known as the sensor controller, is the controller on my hand, and it's doing all the processes here. It's doing all the filtering right here on the hand. And then it makes it into values that you can read, just basic digits ranging from 0 to 10, and sends that data to the receiver. Now we move through the receiver right here, and it further interprets the data. So what I'm going to do now is attempt to demo the project, move the mouse. I turn it on. Oh, whoops, it was already on. So I have a light right here that indicates whether it's on and off, and that works actually pretty well as well. Now see that's off. Now you can move to the left. Now we're going to try to move upwards. There it is. Now we're going to try to move down. Once again, it takes a second to kind of understand the intricacies of it. There it is. Start to move down. And then if you want to move to the right, that. If you do a quick stop right here, it'll stop it completely. I put that into the program, so if you see a very sharp left-right turn, it will stop it so that you can put it wherever you want. And there's the click. Once again, works sometimes, not all the time. So this is the example of the data I was talking about. This is what I am receiving from the accelerometer, and as you can tell, it is all over the place. And so my main job and my main purpose here was to create a digital filter function solely used for an INO file, so the Arduino files that it actually interprets, so that you can use it, so that it will actually be usable, right? And you won't have to be going everywhere. And so here's something that I want to talk about with you. The goal of this was to make the mouse as the application of my main goal. The main goal here is to create something that anybody can use. And so price and usability was a factor for me. I saved about $63 to $70 to make this, and I used Amazon to order most of my parts here. And so this is very simple plug and play on the bare bones. Matter of fact, yesterday, Monday, I fried the main Arduino Uno board that I was using. That's a very big issue, but because I've already made the code itself and it's very simple plug and play, because I've done a lot of the filtering digitally and not, I'm just going to turn this off. Great thing, turning it off. But because of the way I made all code-based, it's very much plug and play, and you don't have to do a lot of the hardware yourself. And then usability. So I have actually made a whole process and a whole GitHub repository with each individual part that shows you how to use the accelerometer, shows you how to use the flex sensor, the button, and every other thing on it. Even as much as the light itself is all detailed through there. And so my main goal is for computer scientists like you, people who are more, I turned you off, but people who are more software oriented, to be able to more freely be able to get into the hardware. Because one thing to understand is this is actually much easier to do if you know a lot about hardware, because you can use resistors and capacitors to cancel a lot of the noise. They have low pass filters already, and they even have digital filters already. But a lot of that takes a lot more complicated understanding and is a lot harder for someone who's more software oriented to get to know, especially as Perry has mentioned earlier in class, we don't have a lot of, or any hardware-related courses here for computer science. So this is definitely a good way for someone that's more used to the software side to get into using the hardware side. This is my current design on the glove. You that are here can kind of see a little better. A lot of wires around. But you have the hand that does all the basic motions for you and the receiver. It's very simple. If you've ever used an actual mouse that's wireless, it's about yay thin, about the size of a nickel. The receiver doesn't actually have a lot of hardware around it. A lot of the hardware problems came from the glove itself. So the next steps I have for the glove, and that's one of the other great things about this is, since it's so freelance, since it's so something you can mess with at any point in time, you can add anything you want. I still have 3 analog pins. I'm going to add extra sensors. And the more sensors you add, more flex sensors you add, you start to get different values, and then you can correlate those values to different movements of the finger. And then you can start to map out the finger itself, because right now you're only mapping out the movement of your hands. But then with more flex sensors, as I've showed, the clicks are working, but you can measure ohm resistance. You can actually dedicate certain ohm resistance for each separate flex sensor as a finger position. And that's when you start to be able to do other specific things with the finger, including typing different letters. So a lot of the challenges, the big challenge for me is filtering out noise. And to clarify that, there's 2 different types of signals that I'm using. I'm using digital signals, and I'm using analog signals. And the difference between them is digital signal varies, and it's like a curvature, and it will go something like this, and it varies on voltage. But a digital signal is very much 0, 1, 0, 1. Noise is less of a problem there. But analog signals, noise becomes a very big problem. To give you an example, of the very basic button addition, when I used it on its own, with none of the other parts running, it was very simple to set up, because I was getting voltage readings of about 9.18 volts, which is what I was expecting because I was using a 9-volt pin. But then when I integrate it into the system, it starts triggering a bunch. And I'm thinking, why is this happening? And when you start reading the voltages, you start to realize the noise coming from the other wires are causing it to read values upward to 10 volts themselves. And that's a big issue. And so a big challenge for me is to understand, all right, I found this issue, how am I going to troubleshoot it? And this is where the limitations I set on myself also become, did you turn on again? This is where the limitations I put on myself starts to become a factor, because I want it to be usable by the software people, so I don't want to make a breadboard that connects to it that uses 2+ resistors and 3 capacitors and a certain circuitry. And so I ended up in having 2 resistors on it to go through it. And that's how I managed, because now I can add 0.5 volts when the circuit is connected, and where the variance was about 9.4 volts to 10 volts when it was just activating, it now jumped to 10.23 volts, something that I can read. And then integrating each individual part was also a process. And that's problems that you will receive with this. So next gen, what I always tell people that use the system and people who start to use Arduinos in the future, be wary of the integration. As I just mentioned before with my problem with adding on the button, noise can come in many different forms. If you've ever charged your phone and you put the wire over the touchpad, it'll start going insane. And that's because the magnetic field coming from the wire will start integrating with the system and it'll start touching things, and that applies everywhere, including here. And so be wary of that, and it's something that's been the biggest challenge. Also testing. Test more. Because you think it'll work, and it might work 3 or 4 times, but the 5th time or the 6th time, it will start to have bugs. And you'll be like, why is this happening? Testing it over and over again will help you with the hardware side. My reflections, I gained a lot of patience because I needed to do things over and over and over again. I needed to read at different sample rates all the time to work on what base values do I need for this very simple filter to work. And along with, I learned to work fast because problems would happen fast. And then they'd be fixed, you would think, but then they would recur. The problems don't always show up consistently. So you gotta be able to hit them when they happen. And then personally, I love the outcome. As much as I've had a little problems, as you've seen, with the clicking on my own, the more I work with it, the better it comes every time. I am Iron Man. End of presentation. So now I'm open to any questions. Thank you. Yes, sir.
So what is your next step for, we saw it moving.
Yes.
Generally, what's your next step to really filter, to finesse it so that
So-
a standard operator, Doug's grandma, would, feel comfortable using it?
All right, so next thing that I would personally do, because right now it's at the point where I think anyone can start to mess with it and use it, I would start to use a more standardized methodology of digital filters. They use Jupyter is a language that I've been using before, and I've actually used it myself to run. Fun fact, we have a class here called Computational Physics. It's a physics/computer science course, and we use Jupyter in that to very much to just use a bunch of different equations, and we use matrices, and we simulate a bunch of things. I actually simulated 2 black holes merging, right? Fun things like that. But you can use that computational technology with the Arduino hardware, and you can actually integrate it into the different libraries and make this Jupyter file usable on the Arduino architecture. But that takes a lot of time. It takes a lot of understanding to understand the equations themselves and where to put the X, Y, and Z components in the equation so that you get it right. And that's one of the things, and that has to do a lot with the simplicity of it. For the computer scientists using it, I don't want them to have to know a bunch of physics equations so that they can properly use the filter themselves. But then I would use that for your grandmother who just kind of wants to plug and play it to use it better. Yes. Good? All right.
Well done, everybody.
I hope this didn't spoil anything for anyone.